Alright folks, hello and welcome to this video example on section 6.1, evaluating nth roots and rational exponents. As always, I suggest that you copy down all of these notes, definitions, examples into your notebook so you have them for future reference and study. So let's get started. First, we're going to talk about the nth root of b, or an nth root of b, which is denoted as it is here, the nth root of b, or an nth root of b, is a solution to the equation x to the n equals b. So it's the number that when you plug it into this equation for x, it makes the equation true. That's what we consider as an nth root. And you know what, I would kind of pause the video and try to digest this sentence and make sure it makes sense to you. Perhaps take the concept of a square root first and go from there. But we say that the square root of 4 is 2. Why is the square root of 4 2? Well, because 2 times 2 equals 4. But how does that relate to this equation? Well, in our case, the number b, okay, that number under the radical, here b is under the radical symbol, here b is 4. So 2 is the answer to the equation x squared equals 4. So that's where the fancy definition comes into play. But you're welcome to just think what times itself will equal 4 when you're taking a square root. But when you're taking a root that's not a square root, when you're taking the third root, or the fourth root, or the 98th root, you have to learn to kind of expand your thinking and think about these differently. So, by the way, this number here, the 3, the 4, the 98, that number n is called the index of the radical. So you can have a radical with various indexes or indices. And that index can be any number. Typically, we've only dealt with square roots in the past, but now we're expanding it so it can be any number. So the cube root of 8, you have to think not what times itself gives you 8, but what's the solution to this equation, x cubed equals 8. Or the fourth root of 81, what's the solution to this equation, x to the fourth equals 81. Or the 98th root of 1,000, what's the solution to this equation? X to the 98th equals 1,000. And as you can see, some of these are a little easier to figure out than others. But the solution to this equation here, what is or x to the third equals 8? Well, what makes that true? And you might recognize, well, if you plug in a 2, that'll make it true because 2 cubed equals 8. 2 times 2 times 2 is 8. What about x to the fourth equals 81? What to the fourth power is 81? And you could test out some whole numbers, and you'd find out that 3 is a solution to that equation, because, as we could show on the side, 3 to the fourth equals 81. Or 3 to the fourth, remember, is just 3 squared times 3 squared, and you know 3 squared is 9, 9 times 9 is 81, so you could break it down like that. But we would say the fourth root of 81 is 3. However, sometimes the radicals can't be simplified, or at least not in a way that's obvious. I have no idea what the x value is here, where we have x to the 98th equals 1,000. I don't think that's very obvious, but it would be some decimal. And it would be whatever decimal that when you raise it to the 98th power, it would give us 1,000. So we're going to learn how to break these down without calculators, with calculators to approximate, and see how things go. But that's the basics of what we mean by an nth root. Now you can also write nth roots as powers. And this is a definition expressly said in 6.1, but the nth root of b can also be written as b to a certain power. And when it's the nth root, the rule is simply take the index and put it underneath 1. And this would be this fractional power or rational exponent. B to the 1 over n is the same thing as the nth root of b. So this allows us actually to write our x's as powers, to write our radicals as powers. So square root of x is equivalent to x to the 1/2 power. Okay? When there's no index written, it's always understood that it's a 2. When you take the cube root of y, well, that's the same as y to the 1/3 power. It's just an equivalent way of writing it. So what do we mean by the 1/2 power? We mean the square root of x. What do we mean by the 1/3 power? We mean the cube root of y. And then, so what about the fourth root of 57? Well, that's the same as 57 to the 1/4. It's just a notational difference, or a new notation of what we mean by rational powers and rational exponents. Now we can take that even further with our notation, and it's not just going to be 1 over something as the fraction. Okay, the fraction doesn't have to be 1 over 2 or 1 over 3, but you can have any type of fraction in the exponent. So for example, here we have a 2/3, we have a 7/4, and how should we interpret that? Well, there's actually two ways to write it, but we can think of 8 to the 2/3 power as the cube root of 8. Okay, that part represents this denominator here of a 3. And then the 2 in the numerator, well, that means we have to square the fraction. So this would represent the cube root of 8 squared. There's one way to look at it. But you can also look at it in reverse order and think about it as the cube root. Okay, remember that denominator has to represent a cube root, that denominator of 3, but we still need a power of 2 on the 8, and you can have 8 squared as the radicand. All right, so whether you have it in this order here or this order here, those expressions are equivalent, and they're equal. They're what we mean by 8 to the 2/3. Similarly with x to the 7/4, that would equal, well, the 4th root of x, as denoted by the 4th in that denominator, the 4 in that denominator, to the 7th, which is equal to the 4th root of x to the 7th. You can write it either way. So this is just learning some new notation of how to deal with rational exponents or fractions in the exponent. In general, we say a to the m over n is equal to the nth root of a to the m, which is also equal to the nth root of a to the m. So you can write it those different ways, and that's how we handle our new notation of fractions in the exponent. Okay, we do have to take a quick side note to make another technical point about principal roots versus taking square roots and real roots. Notice that word real roots there. In this chapter, we're not going to be concerned with imaginary numbers. We might mention them here or there, but I'm really only concerned with the real roots and the real answers to these problems with fraction exponents and different powers. Okay, so you can put imaginary numbers to the side unless we state otherwise. But there is a difference in actually the solution to the equation on the right and the answer to this 4th root of 81 on the left. So previously in this video, we noted that the 4th root of 81 is 3. Okay, and that's because 3 to the 4th equals 81. And that would be a correct response. The 4th root of 81 is 3. However, if you were asked to solve this equation, well, 3 is one answer, but it's not the only answer. You probably remember from your polynomial days that the degree is 4, so we would expect we would expect 4 total answers. However, we're concerned about real roots, so it's okay to have less than 4. But you probably should notice that there is another solution other than just 3. Okay, 3 to the 4th does equal 81. But what else to the 4th would equal 81? Since this is an even power, we could also take negative 3 to the 4th and get 81. Since when you have a negative and you have it multiplied an even number of times, you will create a positive. So when you solve this equation, you do have to account for the fact that there could be multiple answers. There could be a positive root, there could be a negative root. Whereas when you're looking at this expression, we're referring to what's called the principal root. Okay, so when they don't specify a sign, when it's not an equation situation, when they just give you a root, like the 4th root of 81, or maybe they give you the negative cube root of 8, well, that sign in front will tell you what they want you to take. This cube root of 8 automatically refers to the principal root, or just the positive root. And then, if they want you to think about the negative, they'll have to put an additional sign in front. And so, negative cube root of 8, well, cube root of 8 is 2, so this would equal negative 2. So that's a little different than writing down this equation and saying solve it. Because if I said solve this equation, you'd have to find all the possible roots. Now, you might notice, well, with an odd power, this one will only have a solution of x equals 2. Okay, but the takeaway from this slide is that whenever they just write a root, like 4th root of 81, like 6th root of 17, whenever they write that down, they're referring to the principal square root, just the one positive root. Okay, principal square root is always positive. And then, like I did over here, if they throw another sign in front, they want you to make it negative. Okay, but that's different than solving an equation and taking roots of both sides. But we'll look at that in one more example on the next slide. Okay, so let's see how to solve some basic equations. With the equation on the left, x minus 3 to the fourth equals 21. We want to get rid of this fourth power. We want to do an inverse operation to get rid of it. And the inverse operation of raising something to the fourth power is simply to take the fourth root. Okay, so that's what we're going to do here. And you might just anticipate in this example on the right, well, we have a fifth power, so we're going to be taking a fifth root. So whatever the power is that you have that you want to nullify or get to cancel out or get to go away, you're going to want to take that root. So when we take the fourth root of both sides, I'm just going to rewrite the equation here. Fourth root of left-hand side, and I'm taking the fourth root of the right-hand side, so 21, and we're taking the fourth root here. We're doing the action of taking the fourth root, so that means I need to have all the roots represented. So x minus 3 equals, and then since it's a fourth root, we must include plus or minus the fourth root of 21. Okay, and that's because, well, when you raise something to the fourth power, it's going to turn out positive no matter what. So this could end up being a negative expression in parentheses here, and we raise it to the fourth and get 21, or it could be a positive expression in this parentheses, and we raise it to the fourth power, and we get 21. So to account for both of those, when you're taking an even root of both sides, second root, fourth root, sixth root, etc., whenever you're taking that even root, since even powers make things positive anyway, you need to have plus or minus. Okay, then we'll add 3 to both sides. And we have our final answer of x equals 3 plus or minus the fourth root of 21. And that would be a simplified answer to that higher order equation. With the one on the right, we will first isolate the power. Dividing by 4 on both sides, we get x to the fifth equals 32. Okay, and in this equation, we want to take the fifth root of both sides because we have a power of 5 that we want to get rid of. So when we do the fifth root of x to the fifth equals the fifth root of 32, that will simply give us x on the left-hand side. All right, when the index is equal to the exponent, the radical will cancel out or be nullified. And on the right-hand side, we simply have what number to the fifth power will equal 32. What number to the fifth power will equal 32? And you might have to think about that for a second. Try a couple numbers, but it turns out to be positive 2 as the only number that will work. Now, we don't need plus or minus in the case of an odd root because the sign, there can only be one sign that works. If we took negative 2 here and raised it to the fifth power, it would give us a negative result. Whereas if we took positive 2 and raised it to the fifth power, it gives us the positive result, which is what we desire. We want 32 to be positive. So you don't have to worry about plus or minus when you're taking an odd root. But when you're taking an even root, you must have that plus or minus symbol. Okay, so let's summarize the basics of section 6.1. We defined nth roots of a number. We can take any root of any number we want, the nth root of x, and we talked about what that means. We defined rational exponents if we were to do x to a fractional exponent, and we talked about what that means. We talked about principal square roots, how when they just write down a root, they're automatically talking about the positive root. But in the context of an equation, when we're solving, we have to consider all the roots. And lastly, we looked at solving some basic equations when we take the nth root of both sides, fourth roots, fifth roots, etc. And tomorrow we'll look at a little bit more of this information in class. Thanks for watching this video lesson.